So, so today we want to focus a little bit on what we call MTA, which is not the Massachusetts Transit Authority. This is Modernizing Traditional Applications, and I need to update my slide to have that spelled out. But essentially what modernizing traditional applications means is taking an existing application that was written, well, essentially wasn't written for a container originally, and bringing it into a container architecture. So just to introduce myself a little bit more, so I come from a .NET development background. So I've been doing solution architecture work, development work for a majority of my career, really focused on the Microsoft ecosystem. I joined Docker about 6 months ago, primarily focused on Windows architecture. So while a lot of the slides and content that I have prepared for today is very much focused on sort of generically solving the problem of taking an existing app and moving it into a container and sort of managing it in a more modern sort of way, I also want to spend plenty of time talking about Windows. I can jive on Windows for as long as you guys want to talk about it. Lots of really exciting stuff being announced this week, and a lot of stuff has been happening over the last 12 months as it relates to Windows and Docker. So really excited about all those details. So just to set the stage a little bit. So, Greenfield applications for containers have been around for as long as Docker, right? This has been the primary use case. Our customers have been coming to us saying, I'm building a Greenfield application. I'm using the latest and greatest, architectures and frameworks, things that are just naturally a fit for containers. Maybe I'm using Jenkins for an automated build solution. So there's a whole lot of goodness here, right? And the market has obviously responded incredibly well to this, and that's why Docker adoption is what it is. But now we're coming into the problem of, well, okay, Greenfield microservice applications are great, but what about the 99% of my other applications, right? I've been developing and maintaining applications in the enterprise for years, many, many years. Is there a way that I can actually take some of the value that I'm getting out of my Greenfield applications and Docker and CI/CD and infrastructure efficiency, et cetera, and apply that essentially to my legacy applications? So that's what modernizing your traditional applications is really all about. So it's a sort of strategy from Docker's perspective that we're working with our partner ecosystem on to essentially just take your legacy application. It's very simple, right? Take your legacy application, containerize it, and you're off and running, right? One picture shows it all. Now, of course, it's much more complicated than this, right? And that's what we're going to kind of unpack as we go through the presentation today. Especially with legacy Windows applications, I can tell you personally, there's a little bit of heartburn that you need to take into consideration as you're moving from your legacy app infrastructure to a containerized application. But we'll unpack that.
Are we talking about web applications that run on Windows, or are we talking about native Windows applications, or both?
Potentially both, but it depends on the native Windows application. So when we're talking about selecting for the right application, typically we're talking about web applications because it's just the most natural fit. So you can run things like IIS within a container, so that can be sort of your base container, and you can drop your web assets on top of that, and it can essentially run just like a normal.
These containers, it's lightweight and it's heavyweight and it's full-size ones. IIS has such a dependency on the OS that you end up having a very full container.
Yep. They are not small. But they are built on layers like any other container. So and we can go through some examples of how you actually build them out, but essentially, they can be, upwards of, 90 gigs, 45 gigs compressed. That's a Windows Server core image. But once you have that image cached, you can build additional layers on top of it. And then you're really only dealing with the delta. So the delta in the case of a legacy web application might be some compiled artifacts that are in the bin directory. It might be, HTML files, etc. So you're really only dealing with the difference. And you can deal with that on the actual delivery machines. So the Windows nodes running Docker, as well as the Docker Trusted Registry. So you can utilize the caching in that layer as well. So as you're moving those pieces around, you're only moving the deltas.
Well, how do you handle the fact that most Windows apps are designed to run they have long run times. They don't necessarily live and disappear immediately. People say, oh, I'm going to take my Windows machine and put containers in it. And they're basically going to treat it the same way they always did. Let it run for the next 20 years.
Isn't it sort of a myth, though, the containers are just instantly ephemeral?
Exactly, exactly. That was one of the first things I wanted to address. Yeah, I mean, we're really used to, in the Linux world, just attaching to a single process that runs and then dies and then cleans up after itself, right? But that's not necessarily how containers need to be implemented. The great example with IIS is you're attaching to the IIS process, and that can run for a short period of time, or it can run into eternity. So there's really no technical limitation on having a long-running process within a container. It's simply just how you manage and orchestrate that container workload. All right, I'm going to get rid of the architecture here because you guys get this, right? You get why it's, portability is really huge. We deal with customers that have a really hard time just moving their application, right? They've built a MSI that's custom built and does all sorts of little hacks in it. They have no idea what it does. It was built, 10 years ago or 5 years ago. So having all of your artifacts built into a Docker file essentially means that's going to be really portable between your workstations, your on-prem infrastructure, your cloud infrastructure. In terms of security, right? There's security in the runtime. Everyone who uses Docker understands some of the security principles that you get out of Docker. But you can also think of legacy applications in terms of actually securing the software supply chain. So taking your application and moving from one place to another and adding an additional layer of security, like signing the image or scanning the artifacts when it gets into the registry. And then efficiency, which we'll talk about quite a bit. So how do you actually go through the process of containerizing your existing application? We'll go through some of the major components, but here are the steps. So we identify the right applications, and that's really important. So over the past 6 months, we've been working with customers to solve this problem, primarily on the Windows stack. Primarily, they've been ASP.NET kinds of applications, but there's .NET Native and other applications that we've been working with. And identifying the right application to start with is really critical. There are some applications that aren't necessarily a good fit. There are applications that are just written too long ago that need additional refactoring that takes quite a bit of effort. So identifying the right application is really critical. And then containerizing the application using tools like image to Docker, which we'll talk about in a moment, make that process of starting with a Docker image pretty easy. Then we'll configure and secure them, which I'll talk about. We'll compose them and then ultimately deploy them. So identifying the application itself. Now, Windows and Linux, you'll hear some more details through the conference, but we're trying to have sort of a single pane for all of our workloads. It doesn't matter whether they're running on Windows or Linux. We want to make it sort of as easy for us to deploy those workloads and have the engine be smart enough to figure out the right runtime for them. So essentially, it starts with any application that can run on either Linux or Windows, and then we continue to narrow it down into specific framework versions.
But to be clear, you're not taking workloads from Linux, run them on Windows, and vice versa. You've got to choose Docker.
That's correct, yeah. So when we're talking about Docker Enterprise Edition, we can use the universal control plane to actually schedule our workloads for us. So right now in the current version, you can apply a constraint, and that constraint can be basically tied to the target operating system of your container. So I can create a Docker compose file, and it can have a Windows node, it can have a Linux node, and I can say, okay, the Windows service needs to go to my Windows nodes, the Linux service needs to go to my Linux nodes.
Well, this has been identifying the application has been the problem for ages. I mean, we've tried looking at networks, we've tried looking at processes, we've tried looking at it all. Sure. And people still can't figure out who their antecedents and descendants are to figure out what really makes the application what it is. So how are you doing that? I mean, to be honest, OS runtime support, great. Framework, great. You still haven't told me how you figure out what the app is.
Is it safe to say that that's up to the user at some point?
Yeah, absolutely.
No, I'm talking about those people at companies that don't even know what makes up their app, and the fact is that they have a mainframe in the corner that's talking to, and they don't even know that. It's not their problem; it's a technology problem.
You're absolutely right. So you're absolutely right in that there is a human component to this at the current state, right? So there is some knowledge of the application that is a requirement. So that's sort of the assumption here. Now there's absolutely a technical component that we can add to address that, but that's not currently what we have available. There's certainly scanning and other things that we can apply to the application, understand the framework.
I mean, my biggest problem is that most people I talk to do not know what makes up their application. You can go to any person in IT and say, what makes up this application? They'll say, this little part that I work on.
Yeah, that's not Docker's job to figure out. That's the integrators, that's people like Networks, that's people like
That's what the higher consultants talk about.
That's a whole nother, that's not Docker's problem.
I mean, there's a tremendous amount of money that the organization I work for, there's a tremendous amount of money that we bring in on consulting dollars just doing application dependency mappings, right? I mean, it's just, and not just for Docker, I mean, just across the board, right? It could be like Cisco's ACI, it could be NSX, it could be this, it could be anything, right? There's just a tremendous lack of knowledge amongst everybody across the board as to what this app's doing, what services it's talking to, what ports it uses, it's a nightmare, right? I don't know if it's specific to Docker. I think it's just generally people just don't know what they don't know what they don't know.
It's just specific to everything, but the main thing is that if I'm going to start talking about, do this and you say identify the app, I may never even get past that because I identify like not even a tenth of the app. Containerize it and things start failing left, right, and center because we forgot, we did this.
I guess if I was look at this, that's identify the app means that you either have to identify yourself or you have to find somebody to identify it for you, and then you move on.
I wouldn't mind you guys building a tool or working with companies that already do this. Yeah. And bringing it in as part of like, hey, you want to identify the app? We'll give you a head start. There's these 17 companies we can work with that do it.
Yeah, completely appreciate that. So the methodology we have applied thus far is essentially a questionnaire that we hand to IT pros that help them to sort of decipher what their application is and ask the right questions, architectural components, dependencies, but that you're right, I mean, it doesn't solve the issue of, well, I don't know how to answer those questions, right? So that's where currently we're relying on our system integrator partners to get in there and start asking those questions and start to understand the applications. But I think there's a huge opportunity on the technology side combined with system integrators to help us do a little bit more detection and understand what those points are. So I absolutely hear you. It's certainly a challenge and something that we've seen with customers going through this process.
When you finally get that app to identify, you finally get it containerized, what else do you do? I mean, now I have to worry about networking, I have to worry about data protection.
I bet you're going to tell us, aren't you?
I think I will. All right. I will get to that, but before I do, I wanted to share, so once you've identified the app, how do you actually containerize it? So there's a number of tools out there. There's tools that have actually been developed in our partner ecosystem, but there's also tools that we develop in open source. So the Windows-specific tool, actually there's a Windows and a Linux flavor, I take that back, is called Image to Docker. And Image to Docker essentially allows you to point to a virtual machine where an app exists and allows you to select for specific artifacts. So I'll use ASP.NET as an example. So if I wanted to find my ASP.NET applications that exist on a VM, I can run the Image to Docker PowerShell tool, and what that will essentially do is find all the different apps that are running on that server. So it will identify those apps, it will figure out how they're configured, and then it will pull all the compiled artifacts from that application into a Docker file. So that will detect the OS level configurations and will give me a really good starting point for a containerized app. So pulling all those artifacts in. So I could have a VM with app 1, app 2, app n. I can point it to image to Docker to that VM, and it will essentially extract out image files. Again, very simplified, but this is essentially the process for starting the detection of our images on the VM.
That assumes that the application is running inside some kind of known framework, right? So you mentioned ASP.NET. It doesn't recognize just any application, I'm assuming.
Yeah, so currently we have known artifacts. I'll speak to the Windows side first because it's just one I'm much more familiar with. So currently in Image to Docker, there's known artifacts that we go and search for. So ASP.NET, IIS, MSMQ, Windows services, then other sort of basic OS configurations. So those are known artifacts that you need to certainly search for. But again, back to our earlier conversation, there's an opportunity for us to bridge the gap there to allow us to do some detection as well as pull the artifacts into a Docker file.
And now, do you present this list of artifacts to someone to say which ones are actually part of your app? Because you could pull up 1,000,001 artifacts and like 17 million, half of them just don't apply.
Yeah, that's fair. So again, I'll lean on ASP.NET as sort of a good example. So the way that the detector works is it will actually search within the IIS configuration. So we'll pull out everything about your application pool. It will pull out everything that's in your bin and working directories. It will pull out your virtual networks, or sorry, virtual directories. So everything that's in your IIS instance, it will pull out. There's additional things that we're doing, so searching for things like in the GAC. That's one current pain point that we're currently working on, which is, if you've done, everyone knows this, right? You run an application, you try to move it from one server to another, and you forgot there's some random binary in the GAC. So that's one of the things that image Docker can go and actually.
Dead code. I mean, there's code that's ancient. What about, how are you going to, I don't want my images to have dead code, because now I just have to maintain something that doesn't exist anymore.
Sure. Yeah. Back to the system integrator conversation, honestly, where there's an opportunity to go and look at the app more closely and analyze what the dead code is in that example.
So, but then I have, kind of an issue with the image to Docker approach, because it's aimed at a brownfield, right? It's aimed at existing environments, and then the assumption of image to Docker is that the virtual machine is fairly clean, while the real world applies there. Now, virtual machines, they've been running for 5 years, 10 years long, so they'll be full of dead code, artifacts that aren't used anymore, et cetera, et cetera.
So, how many of you, when you went to virtualization, did a physical to virtual container server, P2V?
I did
Yeah.
huge numbers of
And exact same problem. Unless you rebuild it from scratch, that will always be a problem.
Yeah.
There's no automated tool in the world
No.
that's going to give you a perfect.
I think that this isn't the same thing. This is just another way to say, hey, I need to know what my dependencies are. So if you build like a Python app, there's like a command you can run that will take all those dependencies and list them out in a file somewhere. This is what image to Docker is really doing. It's taking everything it thinks and putting this in compose file, and from there, you as the integrator or the customer have to go and figure out, do you need these 7 dependencies or are they dead? But I mean, it's not like when you're done, that's your container and that's it, and you have to deal with it like a VM was.
Well, back in the day, I did a P2V of a guy that did like 30 apps on one system. So what we did was we suggested they just take those 30 apps and migrate them to individual VMs. And they're going, well, how do we do that? It's like, well, you have to still know what is required for that app, but it was all self-contained in one host. But apps today aren't self-contained in one host. They're they're contained in perhaps thousands of hosts. So having dead code across thousands of hosts is actually a big deal. From a support perspective, it's a big deal from like how much container I have to use, how much memory and disk and store and networking to transfer all this. It makes a big deal. Scale changes everything. So, I mean, the company I'm consulting with right now, they literally every 3 months go out and remove the dead code. They just remove it. Say, we don't want it anymore. It's no longer part of their image. But they do that because they don't want to have to support it anymore either. That's very, very out there. Most companies don't do that. But that's because they want to run as fast and as streamlined as possible. Dead code causes all sorts of problems. But when I start looking at this one, you say VM, I'm thinking, no, this is not VM. This is a system of VMs. Does image to Docker work, or any of this stuff work across the thousands of VMs that make up my new app? Because it's no longer one VM, one app. It's hundreds of VMs, one app. And then I have hundreds of services, and I have maybe a couple hundred API calls to other services. And I want to containerize it all.
This isn't a new tool. Like, how many customers would you say are using image to Docker? How many applications have you guys taken?
Well, yeah. So this has been around for months, about 6 months.
Why did you build it?
Well, yeah. I mean, so essentially, we're starting with the model of P2V, right? So this is our starting point.
This is your hypothesis.
This is the first. Yeah. So this is the first iteration.
You guys want to run these things in production. I don't think we're even close to that yet. Yeah. This is just, hey, will it work?
Discovery.
Yeah. Will it blend? I mean, that's what we're trying to do, is will it blend?
Well, image to Docker is P2V, but P2V was one physical server to one VM. This is hundreds of VMs to one.
Demo of 0.9 product. That there's data with an alpha tag, right? I mean, this is, so it's not gonna do all that stuff yet. But they're gonna tell us about some of the other things that they can do, I would imagine.
Sure will. All right. Let's keep going. All right. So this is going to be very similar conversation, but it's worth sort of digging into. So another consideration is taking out or basically operationalizing your configuration. So one of the ideas in the Docker image is you want to keep that image as immutable as possible. And again, this requires some knowledge of the underlying application, but it allows us to essentially identify things like app settings, connection strings, anything like that, and will essentially allow us to map them into like environment variables. So again, this is a process that is relatively manual at this point and requires some level of human intervention, but Docker provides the facilities for managing that across an entire cluster. So once you're able to do that transformation with your app, create that immutable image of your app, then essentially you're just going to manage it like a Docker image with environment variables and things like secrets. So if I wanted to store a secure string across my entire cluster, I can use a secret for that. What's probably more interesting for the Windows folks is applying sort of these enterprise level configurations like Active Directory. So this is every single customer that we talk to says, okay, all this stuff is great, but it needs to work with Active Directory. Now, Microsoft made the decision to not bring all the Active Directory stuff within a Windows container, right? They wanted to make it as light as possible. So what they did is they introduced this idea of a credential spec. A credential spec is essentially a configuration that describes a group managed service account that you want that essentially needs to apply back to your service. So maybe in this example, I have a SQL Server connection between my application and my SQL Server instance, and I have a service account that manages that communication, that authenticates that communication. So I would create a group managed service account that describes that service account. I would then create a credential spec using this command right here, and then I would pass that file directly into my Docker service command. Again, new facilities that we're working on here to make this even easier to use across the cluster. This is sort of the first iteration of this, but it allows us to basically do anything that we can do in Active Directory within our container. So the most common use cases are Windows authentication, SQL integrated security, etc.
Does this work also on the Linux Docker?
Does this work also on
Linux Docker.
It does not. So there's other approaches that you would take for Linux, but no, this is a facility that's specifically for Windows.
This is part of the new release.
So there are parts of this that are actually part of the new release. So I can say we're going to be announcing some details on this, but within the next couple of days. But yeah, so this capability right here, so the ability to do it across an entire service is new in the latest release. This facility has existed in Windows containers actually since their inception.
Do you guys have any plan? I mean, the biggest problem I see is that credentials across containers, regardless of where they are, all have to talk to Active Directory or something like that. It'd be nice to have just one way to do it across the whole Docker ecosystem instead of having like multiple methods. I want a credential spec that just works everywhere.
Yeah, across Windows and Linux, essentially. Yeah. Yeah, so I mean, one of the approaches that we're taking on the Linux side is to utilize secrets. And secrets are, it's essentially encrypted strings that you're persisting across your entire cluster, right? Which is very different, obviously, from what you need to do for an Active Directory implementation. So we started here and are trying to sort of move them towards one another. But fundamentally, they're such different implementations that we need to start supporting them first, and then we want to work towards having a consistent ecosystem for authentication.
Well, I'm just saying, because most of my Linux services actually have to talk to Active Directory. So I want a credential spec for that. I'm not using secrets, I'm using credentials.
Noted. All right, and then we talked about deployment. So ultimately that we're just deploying our existing application just like we would any other app. All right, so I know we're running a little bit short on time, so I'm gonna move a little quicker and let Banjot speak. So we talked about security. So these are some of the results that we're actually seeing from existing applications. Now, Granted, we've worked with a handful of customers at this point, so about a half a dozen customers over the last couple months, just to get some initial data points. But the results are really significant. So thinking like deployment time. So this is a pretty standard one. So it takes generally, when you're using MSIs and you have sort of manual scripts and other steps to actually do a deployment, takes quite a bit of time. So we're finding with customers just using Docker as the standard across their infrastructure, and then the Docker build, push, and deploy process as their standard, they're able to reduce their deployment time very significantly. We're also seeing significant efficiency in their infrastructure utilization. So in fact, I'm doing a presentation in a couple days. We have some folks from the Microsoft IT team that are talking specifically about their efficiency in Azure. And they can equate it to a dollar amount. So just by standardizing on Windows containers for all their applications, they're able to pack a lot more containers in the existing infrastructure and save a lot. I mean, a third of their cost, essentially, their Azure bill, which is, they do actually have an Azure bill, believe it or not. So we're really excited about some of the efficiency savings that you're able to get out of standardizing on Docker. And then we talked about this, right? So this idea, we're trying to bring two worlds together. We want to be able to support the legacy patterns of applications like domain service accounts, Windows auth, IAS management, other things that your IT pros might be used to using. But we want to be able to support that within more modern infrastructure. So utilizing mixed clusters of Linux nodes and worker nodes across an entire heterogeneous stack, and then be able to lay the applications on top of them. So that might look like, we'll talk about that in a second. That might look something like this, where we have an ASP.NET Web API as our backend service, and then maybe we have a Spring Boot front end or something like that that runs on Linux, and we can actually have them within the same application stack. And the Docker EE orchestrator is going to be smart enough to deploy those workloads to the appropriate hosts. And again, a lot more cool stuff coming out around this, but wanted to share this sort of idea that now we're allowing our developers to pick any framework. Doesn't matter whether it's Windows, doesn't matter whether it's Linux. If they start with a Windows application, they want to deploy something like Node or whatever on Linux, they can just choose the right tool and the right operating system, deploy it into the stack, and they're off and run it. So that's a big part of
Include different CPU architectures?
Yeah, so right now, the way that this works is the orchestrator will handle moving those workloads around. It will actually create the virtual networking between the hosts, so you can create the isolation. You can describe all of this within a compose file. So maybe I have the front-end network, a back-end database. I can describe it all in one place, and then the orchestrator will move those pieces around, create the networks in order to make that all happen. So this stuff is really, really exciting. Customers have been asking for this for a while. Yeah.
So the customers that you talked about earlier, how did they go about moving their data in?
So data is an interesting one. So a majority of the customers that I've worked with have been SQL Server, and they've containerized their SQL Server only for dev and UAT. And the reason is they have DBAs that run on bare metal, they have their way of doing it, and they don't want to touch it. Yeah, exactly. So we say that's fine, right?
Back to where we started.
Where we're trying to optimize is in the dev and build experience, and really focus on the app workloads. So we're really not doing a ton with data at the database level for those customers anyway.
I would have a real problem if I'm actually in production using bare metal, going to Docker anywhere inside a test. You should be testing 12 inches to the foot, not 9.
So when I'm talking about dev and test, I'm actually talking about the really closed loop cycle for DevOps, really. So instead of a developer saying, okay, you need on your local machine to install SQL Server Express, and we need to have this integration environment that is the same, we can basically just have a Docker compose file that describes everything that they need. It might have some test data in it that allows them, when they spin up their application, it has foobar, lorem ipsum, whatever in it that allows them to do some quick development.
For quick development.
But you don't have to adopt that, right?
But for full testing, I don't. For full testing, that just doesn't make sense.
Sure, yeah, that's not the use case I was describing.
Well, I think it's different too, right? I mean, I'll do like some of my static website stuff using, using like Nginx and Pelican that said, kind of set all the templates to do that. Well, I just do that on my laptop when I push it out to like DigitalOcean or wherever it may be, right? That's a totally different architecture. I mean, it's close enough, that I can test here and get it there and it works fine, but it's not like
Well,
If I'm doing a cutover, if I'm doing a
98.
DBA cut, or a, database cutover on Oracle, massive ERP system, right? Then I want my physical, I want that entire chain to be as identical as possible on every bit of hardware and memory spec and everything.
I
Right?
think
So
it's-
I think there's a difference between
you
for
look-
tolerances, right?
Yeah, if you look
Problem
at
is
that
you
build
get
pipeline,
99%, you get 99% there, it's that 1% error rate that actually causes the most pain.
I think if you look at that build pipeline though, and you understand the app that you're developing, you've already accounted for the fact that there's a performance testing phase of that application before that goes to production, and you've passed those tests in that part of your build pipeline as a whole.
Awesome. All right. We talked about faster deployment. I think we're running just about out of time. So any questions about sort of Windows in general? I know this is sort of more generic Linux and Windows. I didn't realize there's so many interested Windows parties here. So happy to dive into any other details or answer any other questions.
How does it handle the networking? You said it creates it automatically, and I have to define it in a YAML file, but can you pick it up from what I already have?
I might have to defer to Banjan on that one. I'm thinking sort of the external network capability.
Yeah, I'm gonna answer in a hypothesis because I'm not entirely sure, but I think so. You can attach to existing networks, but what you'll do is basically do a host mode network connection for your container. So we won't pick up what's existing, what the existing networks are, and try to pull them into a compose file. Instead, what you can do is say, let my container connect directly to whatever the host network is for this physical host. And so that would allow you to do that. You guys keep me honest here.
Have you had any success stories going through this yet? I mean, through like an alpha process or anything?
So 2 customers are speaking with me on stage in a couple days, and they're going to talk about the success that they've had already. We're sort of in proof of concept mode. This is more leaning towards the Windows side, my customers that I'm working with. But yeah, I mean, those statistics, those are from those customers, actually.
What was the scope of the project you were working on them with?
So the scope is POC sort of sandbox scope. So existing line of business applications deployed from on-prem to cloud, containerized and end-to-end deployments using a standard build process. So it's not a massively complex scope. We're not doing integration with existing build systems. We're trying to keep the dependencies very manageable. But yeah, I mean, we've had pretty significant success with customers thus far.
What do you expect the start to finish time to be on this kind of project?
So the POC project is scoped for about 30 days. So within that 30 days, we have about 5 days of hands-on keyboard, on-site, setting up infrastructure, containerizing apps, creating compose files, and actually doing the deployment itself. The rest of it is sort of just continuing to explore and allowing customers to kick the tires and do integration testing. So our load and performance testing. So a lot of that actually came out of the last 3 weeks of that POC window, whereby customers were actually testing it against their performance testing tools.
Do you guys have, it sounds like you kind of defined a very rough methodology, but I think as like a partner, it would be great if you guys had like a packaged methodology, like here's all the things you need to do, we'll do the work, but at least you have some kind of baseline to start with. Are you guys developing?
Yeah, absolutely. So that's something I should have included actually. So we're doing a training this week for partners, and we're giving them sort of the alpha iteration of that methodology. So it's a couple levels deeper and more prescriptive than this, and we fully expect our partners to take that and completely run with it. We've seen it already. We've worked with a number of system integrators that are saying, great, we're already doing this. We'll sort of just standardize, that way it aligns with Docker messaging, and we'll go run with it.
Okay, great.
So yeah, we're really good feedback from partners thus far about the interest.
operationalizing projects like this, you find companies that have legacy monitoring, management, performance management tools for their existing stacks. How are you answering that question as you take a customer from an existing stack into this new Docker world? I found that to be kind of a shortcoming in the stack in previous versions.
Yeah, so I don't have a great answer for you on that one. Mostly because I've been doing more on the Windows side, where there's just not as much maturity on logging monitoring. So the answer is more use what you have.
Leverage Docker ecosystem.
Leverage Docker ecosystem. And if there are gaps, we'll help you identify them. That's essentially how we've been approaching it.
I talked a little bit about this when I talked about Docker Enterprise Edition.
So basically, you're saying if I'm using agents for performance management, make sure those agents are inside my container. If I'm using some form of agents to do performance management data gathering, make sure they're in my container.
Yeah, hide them on the container or on the host. So there's actually ways to hook in logging. So there's logging drivers you can apply that you can write them directly onto the host. So as long as your APM understands the segregation of different containers and just reading logs, I mean, you can just easily run on the host, or you can run in the container.
I mean, have you guys published a checklist of like things people like have missed in the past that we should remember?
Yeah, so that's a part of the methodology that we're currently developing. Again, we're sort of alpha right now, beta phase on it, working with partners to harden it. But yeah, I mean, that's a part of it. It's let's get a checklist going, making sure that we're asking all the right questions.
I can see a lot of like, okay, here's the YAML file, deploy it. Nope, doesn't work. Do it again, do it again, do it again. I see that happening for a very long time. But then how do you get over the fact, I mean, okay, I do all that work. I get to the point where I'm really happy with it. But for some reason there's this, and this happened in virtualization, happens in any new technology, is that trust gap. How do you bridge from, I can't trust that, to, okay, it does what I need? This is more of a business discussion, but it's a really important one. Because even if you do all the work, they may not even adopt it because they don't trust it.
Maybe I can talk to that. When I talk about enterprise edition, we're trying to close that gap exactly with the message around what the Docker Enterprise Edition means for enterprise. You know, how do we ensure that they get the validity of the stack, that they understand that they can be fully supported, that it's part of the ecosystem they can rely on, all the pieces you need to actually run this. I'm really passionate about it.
Because I can see doing all this and I get it. I just have people that wouldn't trust it.
Yeah, that's fair. Does it make sense? So any other questions on Windows or modernizing traditional apps? Right on. Hand it off to Banjot.